We continue our lesson on logarithms with solving exponential equations. To solve an exponential equation, isolate the term with the exponent of x, and then take the log of both sides. Let's look at some examples. 3 to the x equals 30. In our exponent lesson, we learned that if we can change the 30 and the 3 to be the same base, then we can set the exponents equal to each other. But I cannot write 30 as a base of 3 because 3 squared equals 9 and 3 cubed equals 27 and 3 to the 4th is 81. So I cannot change 30 to be the same base as 3. But what I can do is something called take the log of both sides. So add a log to both sides. Next we can pull the x out front of the log by using the exponent property that says bring the exponent to the front of the log. So we have x log of 3 equals log of 30. And remember, we're solving for x. Since log of 3 is multiplying to x, I can divide both sides by log of 3. In the calculator, press the log button, 30, close parentheses, the division key, log of 3, close parentheses. So the answer is 3.095, and let's round to the nearest thousandths. So the answer would be 3 and 96 thousandths. Next example. Remember, to solve an exponential equation, you need to isolate the term with the exponent. So that means I want to isolate 5 to the x power. So let's subtract 14 from both sides. So 5 to the x equals 7. I notice that I cannot write 5 to be a base of 7 or 7 to be a base of 5. That just will not work. So now I take the log of both sides. So this is exactly the same problem as we had over here from this point. So log of 5 raised to the x is equal to log of 7. The next step is to bring the exponent to the front. X times log of 5 equals log of 7. And since we're multiplying log 5 to x and we're solving for x, divide both sides by log of 5. So x is equal to log of 7 divided by log of 5. So let's figure this out in the calculator. Log of 7 divided by log 5 equals 1.2090. If I round to the third decimal place, that's 1 and 209 thousandths. Next example is just like the one we just did. Remember, we have to isolate the term with the exponent first. So that means we need to add 4 to both sides. Now the problem is just like the first example. I cannot change 10 or 38 to be the same base, so I need to take the log of both sides. Then the exponent pulls out front. And since we're solving for x, divide both sides by log of 10. So x is equal to log of 38 divided by log of 10. Log 38 divided by log of 10. And the answer is 1.5797. Remember, we're going to round to the nearest thousandths. Since 7 is bigger than 5, means I need to add 1 to 9. So that's going to be 9, 10, 7, 8. So it's 1.580. So it's 1/580 thousandths. Next example. Notice the number with the exponent is already isolated. So we just need to take the log of both sides. Now bring the exponent out front. Since we're solving for x and I have two things being multiplied to x, we're going to divide by 4 log of 2. And this is what we put into the calculator. Log of 3.6 divided by log of 2. Get our answer of 1.8479, but remember I still have to divide by 4. And the answer is 0.46, round this up, 462 thousandths. Another way to put this in would be log of 3.6 divided by, at this point, open up parentheses and put the 4 here, log of 2, close parentheses twice, and we get the same answer as above. The only problem with this is most students forget to put in a negative sign. They forget to put parentheses here, and they forget to close off the second set of parentheses here. And if you do not do those 3 things, you will get your answer wrong every time. So the first way, just divide the logs and then divide by that number last, will keep that from happening or keep you from making mistakes. Last 3 problems are refutable and we are done. Let's look at this example first. Notice my exponent has more than one number in it, or one term. It has 2 terms in it. Does not change what I'm doing. I look at the bases and notice that I cannot write those as the same base. So let's take the log of both sides. The next step is to bring the exponent to the front. Notice we're doing the same thing with every problem. But this exponent is 2 terms. Since it's moving out front and being multiplied to log of 19, we have to put this in parentheses. So more than one term, put it in parentheses. Now let's divide both sides by log of 19. So we have x plus 4 is equal to log of 3 divided by log of 19. So let's figure this one out. Log of 3 divided by log of 19 is 0.3731143. Subtract 4 from both sides. We get negative 3.626, but remember we're rounding up to the 3rd decimal place, so it's 3 and 627 thousandths. Negative 3.627. Don't forget the negative sign. Next example. I need to isolate the base with the exponent. This means I need to get rid of the negative 4 first. 3 times 1/2 to the x power equals 15. The next step, divide by 3. So 1/2 raised to the x is equal to 5. Now this is exactly like the problems that we've been doing. I cannot change these to be the same base, so we're going to take the log of both sides. The exponent moves out front, so x times log of 1/2 equals log of 5. And divide both sides by log of 1/2. So x equals log of 5 divided by log of 1/2 is negative 2.3219, round to the 3rd decimal place, negative 2 and 322 thousandths. This is an example just like we did on our last unit where we're talking about compound interest. We're given a formula. We need to plug it in. Let's find all of our players. Scott invests $6,000. So this is our P. That's what we're starting off with. 8% is our rate, and we need to change that to 0.08. Compounded quarterly is N. Quarterly means 4 times a year. How long will it be? That's time. And how much has it grown is 14,000. That's A. So A is 14,000. P is 6,000. R is 0.08. N is 4. And T is, we don't know, question mark. So let's fill in all of our key players. 14,000 is equal to 6,000 times 1 plus 0.08 divided by 4 raised to the 4 times t power. To solve this, let's look at PEMDAS to help us out. PEMDAS says take care of parentheses first. So we have 14,000 is equal to 6,000 times, let's put this in the calculator, 1 plus 0.08 divided by 4, 1.02 raised to the 4 times t power. PEMDAS says take care of exponents next, but I can't because I don't know what t is. So the next thing I would do would be to get rid of the multiplication division. So let's divide both sides by 6,000. On the left-hand side, reduces to 7 over 3. 2 goes into 14, 7. 2 goes into 6, 3. On the right-hand side, we have 1.02 raised to the 4t power. Now I've got the same problem I've been working with since we started this lesson. Let's take the log of both sides, pull 4t to the front, and since we're solving for t, we need to get rid of the 4 and the log of 1.02. So 4 times log of 1 200. Let's divide both sides by that. So t is equal to, let's put in log of 7 divided by 3 divided by log of 1.02. Get 42.787. Now divide that by 4 because I haven't divided by 4 yet. And the answer is 10.697 years because we rounded up. So T is 10.697 years. Word problem, word answer.